Hello, this is section 3.4. So we're going to work in solving system of linear inequalities using a different approach. Basically, we're going to use matrices to solve systems. So these are the objectives. So first, we're going to work in setting up the solution of a system of linear inequalities using augmented matrices. Right. So we're going to see how that works. Okay. And then after that, we're going to perform row operations. Right, so first we're going to work with augmented matrices. Then we're going to perform row operations on a matrix to solve these systems. And then we're going to talk about special cases, which are dependent equations and inconsistent systems. Basically, a dependent system is one that have an infinite number of solutions. An inconsistent system is one that has no solution. Okay? So a matrix. A matrix is defined as a rectangular array of numbers. But in our case, we're going to see how that relates to linear equalities, right? So this is a 2 by 3 matrix, right? This is the number of rows, and this is the number of columns. You can see that we have 1 and 2 rows, 1, 2, and 3 columns. And here we have a 3 by 4 matrix, right? So 3 rows, 4 columns. Okay, so last time you guys were working with a system of linear equalities, such as this one. Okay, so what we're gonna do is that we're going to write this in matrix form or augmented matrix. You can see that here below I have an augmented matrix. You can see pretty much that these are the coefficients of the variables, right? So if I remove, this is a 1 here. So if I remove the variables, okay, these are the coefficients of each of those variables for the first equation, for the second equation. Okay, this is a 0c. Okay, so this is the coefficients for the c variable. And here we have equal to the result, right? That 12 goes here and the 16 goes here. Right? So this matrix represents basically that system of linear equality. Right? So we're going to use this augmented matrix to solve the system. Okay, so we're going to see how we're going to do that. Here we have the same. We have 3 by 4 system, right? So we have 1, 2, and 3 equations. Okay. Again, the coefficients for the x goes here. So here we have a 0. Actually, no. Here we have a 1 for the x. For the 0, this is plus 0y. So this is 4 minus 1 and 0. You can see here 4 minus 1 and 0. That's for the y. And for the z, we have minus 2, 1, and minus 6. Okay, so again, the augmented matrix form for the system of equalities is here, right? So this bar is basically the separation from the left to the right side. Okay, so here basically we're going back. It says write the system of equations that represents each augmented matrix. So here we have the rows, which represents the equations, the first and the second equation. Here we have the variables x and y. Well, that's pretty much the standard, equal to the numbers on the right side. So this will be 4x minus 5y equal to 15. That's what we have here. 7x plus AY equal to minus 9. That was what we have here. Right, this is to practice to go back and forth between the system of equations and here in this side matrix form. Here we have another system, right? Augmented matrix. Again, writing this in equations. Here we have x, y, and z. And these are the operations. So the first one will be 2x plus 0y minus 6z equal to 3. So you can get rid of this 0y, right? We don't need it there. Minus ax plus 7y plus 3 equal to 12. And the third one, minus 5x plus ay plus 4z equal to minus 3. Okay, so here we have that system. Okay, so with matrices, you can do pretty much the same as you did with the system of equations. For example, you can interchange any of two rows. So let's say that I have this system of equation, 2x plus 3y equal to 6, 6x minus 5y equal to 8. It doesn't matter, I can change the order of these equations, right? I can place the second equation on the top, this one, place it here, and it's pretty much the same system. So doing that with matrices will be the same. You can multiply all entries in a row by a constant. So we have done that. For example, I can take and multiply this equation by 3 in both sides of the equation. So now this becomes 6x plus 9y equal to 18. Right? So that will be performing this action. Okay, and it says replace a row by the sum of that row, that's number 3, and add a non-zero multiple of some other row. So this is key, right? We're going to be doing this to eliminate variables. That way we can solve the system, right? So we're going to see this in detail later. Okay, so here we have an example where row 1 and 2 were interchanged. Be careful that we have to change everything, the left and the right side of the equation, right? So this goes to the bottom and the second one went to the top, all right? Row operations. This is the case of number 2. Here we're taking all row number 2, right? So this is all row 2. We multiply that by minus 2 and we get a new row 2, right? So technically it's multiplying the bottom part by minus 2. So what do we get? Minus 14, minus 16, and 18. Okay, 2 times minus 7, minus 14, minus 2 times 8, minus 16, minus 2 times minus 9, 18. Okay, that's the row that we get down here. this one. Okay. Here we have some manipulation. Here we multiply 4 times row 1 . Let me get my pen. 4 times row 1, and we add row number 2. So for example, and we get a new row 1. This is important, like which row are we going to change? So for example, if I have my matrix, I'm not changing row number 2, that stays the same. But then here, for this entry here, this will be 4 times the value for row 1 . So that will be, let me go down here. So this will be 4 times 4, and then we add row 2 plus 7. This one here will be 4 times the whole row, 4 times minus 5, and we add 8. And the value that goes here will be 4 times 15, and we add minus 9. Okay. So you can get the values. This should be 35. This should be minus 12. And this should be 51. Oh, sorry. Sorry, 4 times 4 is 16, so 23. Okay, those are the values that we see right here. Okay, so this is row manipulation. Okay, we're gonna see that we're gonna use that later to eliminate variables. Okay. So it says here, for the augmented matrix, so it says find a row operation that will result in the entry in row 1, column 2, row 1, column 2, this one right here, to become a 0. Right, so basically what we want is this row here, or this value to become a 0. Right, so the way you do that is that you will need to add 5 to that. So to get a new row 1, I will have to take the first row and add 5 times row number 2. Why is that? Because I want to eliminate this value. I want to eliminate this value. So the way I can do that is by multiplying this row by 5 and adding these two together. These two together. Okay, but if I multiply by 5, I will have to multiply this also by 5 and this by 5. Okay, so this is the row operation that I need. 5 times row number 2 plus row number 1. Okay, so I will get something like this. Okay, a new operation. So this becomes 1, 0, 28, 0, 1, and 4. Actually, let's take a look at this in the system of equation. You know, if this is my X and Y columns, and this is row 1 and row 2, let's write this as a system of equation. I have X plus 0, Y is equal to 28, 0 plus Y equal to 4. You can see that technically what they're saying here is that x is equal to 28 and y is equal to 4. So this is actually the solution of my system. We're going to see later that we're going to have a matrix, and we want that matrix final form to be something like this. Okay, because that represents the solution of my system. So we're going to perform row operations, either interchanging rows or things like that, to finally get something like this. Okay, so let's solve the system. Okay, so we're gonna have we want the matrix to be in row echelon form. Okay, it says row echelon form is when the entry in row 1, column 1 is a 1 and zeros appear below it. Basically this. Okay, it says the first non-zero entry in each row after the first row is a 1 and zeros appear below it, and it appears to the right of the first non-zero. So basically what they're saying is that after that we want to have 1s and zeros below. Okay, why we want that? Because here, if I write this as a system of equations, I have x plus 5y minus 6 equal to 3. Second equation will be y plus 3c equal to 12. And the last one is c equal to minus 3. You can see that by having my system of equation in this form, I can actually find all the variables. Because since I know that c is minus 3, I can take that value, place it in this equation, and find y. And then I can take x and y, place it in this equation, and find x. And then I will have x, y, and c. Okay, so technically we are going to work to have our equation in row echelon form, where we're going to have 1s in the diagonal, and we're going to have zeros just below all the 1s. Okay. So, I mean, when working with systems like this, it's just a matter of being patient, right? So patience is important. Now, why we want the systems in matrix form? Because actually we can, by having this in matrix form, like this, 3, let me just get rid of this, throw it down here. If I have it in augmented matrix form like 3, 11, 1, 5, 13, and 7, I can use tools like computers, calculators, to actually solve this, right? That's why this is better, because I can use tools to solve, right? It can be programmed, and there are matrices that are larger than this, like 10 by 10 matrix, and even larger, where it will be practically impossible to do it by hand. Okay. So what we want is that I would like this later in row echelon form. So I'm looking for this to be like 1, 1, 0. Here I could have any number. Yeah, here I'm gonna have also any number. Okay, but this will mean that y is equal to this number, and then I will be able to solve, right? This is what my target. Okay, so this is the matrix of this system of equations. Okay, so again, since I have in mind what I need, which is 1, 1, and a 0, there are many things that I can do. One thing that I can do is that I can replace row 1 or interchange row 1 and row 2. Why? Because that will place this one in my first entry, right? So I'm getting there. I'm getting closer. Yeah. Now, I would like this number to be a 0. So to get that, I will multiply row number 1 by minus 3 and add that to row 2 to get a new row number 2, right? Basically, this number here is going to be minus 3 times 1 plus 3. That way that gets to be a 0. Again, thinking in my ultimate or my final destination, which is 1, 1, and a 0 below. Okay. Now, next thing, I need this number to be a 1. So I'm going to divide row number 2 by minus 4, because if I divide this by minus 4 and divide this by minus 4, this number gets to be a 1. And here, this is minus 8 by minus 4, which is 2. Okay, so now my matrix is in row echelon form. Now I know the value of y, which is 2, right? So this means that y is equal to 2. And then I can plug that value in my first row to get x. Okay, so the first row represents x plus 5y equal to 7. The second row we have y equal to 2. So I can take that value, plug it here. X plus 5 times 2 equal to 7. Okay, so now we just solve, right? X equal to minus 3. So remember to check your answer. Okay, so you can just take the original equation. Let's look for that equation here. Right, so you can take your original equation, which is this one, okay, and check with x equal to minus 3, y equal to 2, and see if you get those numbers. So you can pause the video at any time. Okay. So here we are just checking the answer. Okay, so this is the check for the first equation. This is the check for the second equation. I plug in the values minus 3 and 2 in the original equations. Okay, here we have a 3x3 system. Okay, so pretty much it's the same situation. The only thing is that with 3x3 system, it just takes a long time to do them, right? So being patient and being methodical is important. But again, the row echelon form will be 1, 1, 1, 0, 0, 0. Let me just write it down here. Row echelon form 1, 1, 1, 0, 0, 0. Here you're gonna have just numbers, we don't know which ones. And that in the right side, numbers. Okay. So it's like playing chess, right? You just come up with different strategies. Okay. You can remember you can interchange rows, multiply by constants, or perform operations. Okay. Doesn't matter the order. The only thing is that you need to end up with a matrix in row echelon form. Okay, so let's just go through what they did here. Okay, so writing in augmented matrix form, okay, basically just getting rid of the variables and the equal symbol. Okay, so here you can see that the first thing that we can do is put this on the top and also divide by -1. Why -1? Because I want this number to be +1. So I need to divide everything by -1. Let's see if they follow that. Okay, so here the interchange with row 2, 3. They could also have done row number 2. It doesn't matter. Well, here the divide or multiply by -1 is the same. Just to make it positive, right? So I'm getting there. Now the other thing that I need is just to have zeros in here. Okay. So here row manipulations could be anything, right? The only thing is that I need a new row number 2 and a new row number 3. The way you get to have zeros there, this could be anything. There's no right or wrong in how you do it, right? You could use row operations within row 1 and 2, or row 2 and 3 to get it. Okay. So let's see the order that they follow. Okay, so here to get a new row number 2, they multiply row number 1 by -3 and add row number 2. Again, here, if you take -3 times 1 plus 3, you get a 0. That's the objective, to have a 0 here. And then to get a new row number 3, they took 6 times row number 1 and add that to row number 3. Again, because here, if you multiply 6 times 1 minus 6, you also get a 0, right? There are many ways to do it. For example, another way to do that, you could have taken 2 times row number 2 and add row number 3. Will be the same, right? Because here you get 2 times 3 minus 6. You could also do that. Okay. I would have preferred to do this. Why? Because I don't have to deal with this fraction anymore. Okay, so let's see how that goes. Okay, so here, please take some time, pause it, do the row operations, see if you can get these numbers. Okay, again, you can see we have the fraction. And here we have a special situation where row number 3 is all zeros. Okay. So this is what we call a dependent system. We don't have technically a solution here. Why dependent? Because if you put this in the system of equation, x minus 2y minus 1/2 c is equal to 1. Here I have 10y plus 1/2 c equal to 2. Okay, here I got nothing, 0 equal to 0. You can see here that the values of x and y technically depend on c, right? So because here I don't have a solution for this variable for c, so what I have to do, I have to come up with a number for c, and then I will be able to get combination for x and y. So this is a dependent system. Okay, dependent system, right? So they're going to ask you to be able to identify this. This is the case of an inconsistent system. I'm not going to go through the whole solution of it. I'm just going to explain what it is. So here, if I write this in a matrix form, which is what we have here, and I start working with my solution, right? Trying to get this in row echelon form, right? So here, basically, I'm just performing operations to try to have all ones in the diagonal, like this. Okay, so interchanging rows, multiplying by constants. Here, so, I kind of like breezing through this, but, just please pause and work on the matrix. So the other thing that I need to do is to try to get a 0 here. Okay, so here performing the operation, 2 times row 1 plus row 2, sorry, trying to get 0 here. Okay, this will get to do that. And then we want entry row 2 in column 2 to be 1. So we want this to be a 1. So how do I get that? Divided by -5, everything. Multiplying by -1/5. Then what is next? Trying to get here a 0. Right, so here I perform this operation. -5 times row 2, which is -5 times 1, plus 5, trying to get a 0. And now I get something like this. Okay. So remember that before this was a 0, but now here I get something that is inconsistent. Okay. So this has no solution. Okay, so therefore the solution to this system is null or empty. Okay, so we work with system that has. So we work with system that has solutions. Okay, and also with system with no solutions. So like inconsistent. Okay, so no solution. A dependent system has multiple solutions. Okay. Let me go back to dependent system. So here we have a dependent system with an infinite number of solutions. Okay. So we're going to jump later to section 3.5 to work with as a tool that we have to determine the type of solution that you get with matrices.